Hi guys, my name is Francesco Pecora,
Hey, I'm Mobin Chowdhury.
and we are research students working on a research project under the supervision of Professor Aleksandar Haber. This is our second video about the inverted pendulum project, and today we're going to show you how to set up the relative rotary encoder to measure the horizontal displacement of the cart. The cart is attached to the pulley using a belt, and the pulley is connected to the encoder, which is sitting underneath the base. This is our rotary encoder, and it provides angle measurements. However, we need to convert these angle measurements into horizontal displacement. To find the effective radius, we use a distance gauge. For a known angle of rotation, we are able to precisely measure the horizontal displacement of the cart. Now we're going to show you how to find the effective radius. Arduino is providing us an angle in degrees, but we need to convert this angle into radians. From basic mathematics, we know that 360 degrees is equivalent to 2 pi radians. Therefore, we can say that 1 degree is equals to 2 pi divided by 360 radians. Now we can see that if we want to convert our angle in degree to radians, we need to multiply it by 2 pi over 360 to eventually find our angle in radians. This is our pulley, and this is our belt. Our pulley has a radius of r. If we rotate our pulley for an angle alpha, we can see that the displacement, delta x, is equal to the displacement traveled by the belt. Delta x is an arc length, which is equal to r times alpha, and it's important that alpha is measured in radians. From this equation, we can find the equation for r, which is equal to delta x divided by alpha. Since our delta x is provided by the distance gauge and alpha is provided by Arduino, we're not able to calculate our effective radius.